Let's just imagine that you were trying to understand a significant cause of infertility in human males. They just can't make sperm. But you were really trying to understand why. Why can't they make sperm? What is actually wrong? Because if you knew exactly what was wrong, there are technologies that are emerging right now that might give you a way to fix it.
Infertility affects 10 to 15% of couples, and one of the contributors to infertility are defects in meiosis.
We've wanted to understand why exactly the process is failing at that point.
We're really interested in better understanding how chromosomes separate, and that's really important for making eggs and sperm that function properly. And one aspect of that is a large protein structure that forms between chromosomes.
We were focused on a tiny little region of one protein in this gigantic structure that we were pretty sure could be the cause.
We created mice that had defects in this protein that forms between chromosomes. So the proteins that form between these chromosomes during meiosis, they form this ladder-like structure where they interact with each other, and mutating a single amino acid disrupted the ability of that protein to interact.
We're talking pinpoint surgery here. We're talking about changing a single amino acid in a huge protein encoded by a gigantic genome.
So instead of joining together, they were instead separate.
There were no sperm because they couldn't complete the very earliest part of meiosis. And this gives us a completely different way of thinking about this structure.
If we think about like a drawbridge, two sides that have to come together and they have to interact for that to be a fully functioning drawbridge, we made it so in the middle they were unable to come together and interact to make an intact roadway. So that's really exciting to me that our research can help us better understand this really basic process that's necessary for life.
And I would not have said this a year ago because I didn't think the technology was anywhere near close enough to imagine it. But because of work done in a large number of laboratories around the world, I can now begin to imagine ways to fix this.